Welcome. Today we'll be talking about pole and polars, which are related to circles. So first we'll define what a pole and polar is, and then I'll tell you an interesting property regarding it. Alright, so let's get started. So first let's take any random circle whose equation is x square plus y square equal to a square. Okay, the circle is centered at the origin, so it makes the calculation simple for us. And let's take any arbitrary point a whose coordinates are x1 comma y1. Now we draw tangents, we draw a line which cuts the circle at 2 points and which also passes through a. Okay, so it's basically a chord of the circle which passes through a. So we just take this chord as an example. Alright, so let it intersect the circle at points b and c. Now what you do is draw tangents to the circle at these points, right? And let the tangents intersect at a point P whose coordinates are h comma k. Now we are interested in this point P. Okay, we are going to find the locus of this moving point P, and that locus is called the polar of point A with respect to the circle. Alright, and now we have defined what a polar is, right? So what is a pole? Here in this case A is the pole, right? This is the pole. So we drew the common chord passing through A to the circle, right? So the initial point which you took is called the pole. So in this case this is called the pole, and the locus of P is the polar of A with respect to circle. Alright, so now we'll find the locus of point P. So if we work from the perspective of point P, we see that we have drawn two tangents from point P to the circle, right? And so we can find the equation of this common chord, which is pretty direct. It's just t equal to 0, right? And we know what the expression for t. Alright, it's just x1 plus we'll use another variable x dash plus y dash minus a square equal to 0, where x dash and y dash are the points from which you draw the tangents. In this case it's h comma k, so let's just substitute that in here. Xh plus yk minus a square equal to 0. So this is the equation of BC, right? And now we also see that BC passes through A, so x1 comma y1 must lie on BC. So it's a solution of this equation, right? So let's just substitute x1 comma y1 in place of x. So x1h plus y1k minus a square equal to 0. And now we can just, and now except h comma k, all the other things are constant, right? So we can just replace h and k by x and y. Okay, it makes things a lot more clearer. x1x plus y1y minus a square equal to 0. And this is the equation of polar. This is the equation of the polar. Equation of the polar, or equation of the locus of point P. That is the polar of point A with respect to the circle. And you must be noticing that this and this expressions are pretty similar, right? So well, what we did was, in this equation, this was the equation of the common chord, the chord of contact of P with respect to the circle, right? But in this case, this is the equation of the common chord of the chord of contact of point A, which is x1 comma y1 with respect to the circle. So essentially what we have is, if you have a circle and if you have a point A which is x1 comma y1, and if you draw the chord of contact, this also happens to be the polar of point A with respect to the circle, right? So this is a coincidence. Alright, Alright, so we found the locus of the polar. Alright, so now we have defined what a pole is and what a polar is. Okay, pole is just the point and polar is the locus of a point. Alright, locus of a moving point, which we and the condition was that we from A we draw chords to cut the circle at 2 points, and if we draw the tangents at those 2 points to the circle, they intersect at point P, and we just need to find the locus of point P, which gives us the polar of point A with respect to the circle. Alright, so now let me tell you an interesting property regarding this. So consider a circle and take 2 points, A which is x1 comma y1 and B which is x2 comma y2, and draw the polar of point A with respect to the circle. So it's just the chord of contact which we found out earlier, so let's just draw it. Alright, and now let's not take B here, let's take a point B on the polar of point A. Okay, so B lies on the polar. Alright, and now let's draw the polar of point B. Okay, it's again the chord of contact. Alright, and now what the property says is that if you draw the polar of point A and a point B lies on that polar, then the polar of B passes through the initial point A. So in this case, what I mean is this polar passes through A. Alright, so let's prove it. It's pretty simple. Let's first write the equation of polar A, polar of pole A. Alright, so it's just xx1 plus yy1 minus a square equal to 0, and we see that x2 comma y2 lies on it, so x2 comma y2 satisfies this equation, so we can write x1 x2 plus y1 y2 minus a square equal to 0. And now let's write the equation of polar of point B with respect to the circle, which will be x2 plus y2 minus a square equal to 0. And now if you just substitute in place of x and y, if you substitute the coordinates x1 comma x2, we get x1 x2 plus y1 y2 minus a square equal to 0. I mean not equal to 0. Let's consider this an expression. Alright, and we have this expression. Now notice that from this result, this is equal to 0, which implies x1 comma y1 satisfies this equation, that is the equation of the polar of point B, which implies x1 comma y1 or point A lies on this polar, and this proves the property. Alright, so let's just have a recap. We first define what a pole and a polar is. Alright, this is the pole and the locus of a moving point P is the polar, and we derive the locus of point P, which is the polar and we got this as our answer, which is just the equation of chord of contact. And then we just talked about an interesting property. Alright, that if a point lies on the polar of another point, then that point lies on the polar of this point. I mean, okay. And in this case, there's a specific word for this. These 2 points are called conjugate points, right? And these 2 lines, in this case these 2 polars, are called conjugate lines. Alright, and that's it for this video. I'll see you guys in the next one.